Hello my dear students, how are you? My name is Josiah Mwakitalima. I'm a chemistry teacher from Kidato Secondary School. I'm here to discuss with you issues or challenging that are emerging in chemistry subject. So I warmly welcome you and make a follow-up on me so that you can solve those issues or problems or contradictions that are happening in chemistry subject. And currently we are going to start with a topic known as relative molecular mass in solution. So our subject is chemistry, and the main topic is relative molecular mass in solutions. And this topic is a topic of physical chemistry, and according to our syllabus is a part of Form 5. And according to the new format of chemistry, the questions from this topic appear in chemistry paper 1. So please don't confuse yourself, because most of students are now confusing themselves about the new format. The new format is only about the arrangement of questions, but the content is still the same as it was like in the old format. So please don't confuse about these issues that most of the students are now confusing themselves about the new format. So it is a part of paper 1 chemistry, and it is a physical chemistry topic in Form 5 students. And this topic have 2 subtopics. And so our aim here will concentrate on the subtopic known as the laws governing the colligative properties. So we have our subtopic that will now consider is laws governing colligative properties. So that is our subtopic that we will consider now in our discussion. And the main issues that will be discussed under this subtopic, which are contradicting most of the students, we'll discuss about the boiling determination, of boiling point elevation, and secondly, we'll discuss about the determination of freezing point depression. So these are the two main key issues that we are going to discuss under this subtopic. So after our discussion, I'm sure that every student will be now competent in using the knowledge and the skills and the theories of chemistry in solving day-to-day life situation. Normally, the solute that have been added into the solvent, one is that the non-volatile solute occupies the interstitial spaces, thereby holding the solvent molecules together and making it difficult to escape and form a vapor phase. So that is what is happening when a solute is added into the solvent. Second is that some solute have an effect of forming a thin layer over the surface of the solution. So if they form a thin layer of the surface of the solution, it will make it difficult for the solvent molecule to penetrate and form the vapor above the solution. That some solute particles have a tendency of forming a thin layer above the surface of the solution. Now, from this concept now, we have the theories of colligative properties that you don't need to state them here because I know you know them. But what does the theory tell us about these properties? Now, starting with the boiling point elevation, as we have seen here that the boiling point of the solution now increases, so it becomes higher than the boiling point of the pure solvent. So the theories tell us that the change in a boiling point elevation is directly proportional to molarity, whereby change in T, P, is what we call it the boiling point elevation of the solution. As we have said that since there is an increase in temperature, that means we have a temperature that increases from a certain amount to a certain amount. So we have the change in temperature. So how do you get the change in temperature? So the change in temperature now, which is change in TB, will be equal to temperature of the solution then minus the temperature of the solvent. So to get the amount of temperature that will be elevated or that will increase from that of the solvent to that of the solution, you just take up the temperature, the boiling temperature of the solution, then minus the boiling temperature of the solvent. Now, from our equation above, from the equation change in TB, which is the boiling point elevation, which is directly proportional to molarity. So by removing the proportionality sign, then we put a constant value which is known as Kb, and it is known as the molar boiling point constant, or sometimes we call it ebullioscopic constant. So change in TB will be equal to Kb then times molarity. And if we call now from the formula of calculating molarity, so if we call now from molarity, we said is equal to number of moles of solute over mass of solvent. Let's call it to be W not, but in kilogram. And the number of moles of solute, that let us abbreviate it as small letter n. That is molarity. Therefore, molarity now is equal to N over W naught, whereby N stands for the number of moles of the solute and the W naught stands for the mass of solvent, but the mass of solvent is in kilogram. Now, if we continue now expanding our equation, number of moles of a solute is equal to mass of solute, which is, let us call it as Ws, then divide by the molar mass of solute, and let us call it as to be Ms. So number of moles of a solute is equal to Ws over Ms. Now, if we substitute this value to our equation there of change in TB or of molar boiling point elevation, so substituting these into the boiling point elevation equation, so change in TB will be equal to Kb times molarity, but now molarity will be equal to N over W naught, which is the mass of solvent, but that mass of solvent is in kilogram. Now, but N is equal to Ws over Ms. So if we also substitute N by Ws over Ms, now our equation will be change in TB will be equal to Kb, then N is Ws, so will be Ws over Ms, then times W naught. Mind you that here is where now most of the students are also confusing this equation, because we know that here the mass of a solvent should be in kilogram, but most of the questions, the mass of solvent are being given in terms of grams or in the units of grams. So what do we do here? We divide our mass of a solvent by 1,000, because 1 kilogram is equal to 1,000 grams. So in that now, our equation change in TB will be equal to KB, then WS over MS. But this W naught is the mass of solvent in kilograms. So to change it into gram, we divide it by to change it into kilogram, we divide it by 1,000. So our equation now of change in TB will be equal to KB, WS, then times 1,000, then divide by MS, then times W naught. So this is now our equation that guides us in determination of the boiling point elevation of the solution. So from this equation now, you may be asked also to determine the relative molecular mass of the solute, because one of the applications of the colligative properties is in determination of molecular mass or molar mass of the solute. And the molar mass of solute, we have said that it is denoted by MS. So if we make MS the subject now, so making MS the subject, our equation will be MS will be equal to KB WS times 1,000, then divide by change in TB, then times W naught. So that will be our equation, which is the main important point to consider the application of colligative property, that they are used in determination of the molar mass or molecular mass of the solute. So this is now our equation that we use it to solve different types of questions involving boiling point elevation. So whereby KB stands for molar boiling point constant, WS stands for the mass of the solute, and the change in TB stands for boiling point elevation, and the W naught stands for the mass of a solvent in kilogram. Now let us consider for the case of freezing point depression. Here we were talking about the boiling point elevation. That means after adding the solute into solvent, how much of the temperature is being increased. That is what we call it the temperature, or the amount of temperature that have been elevated or has been increased, which is obtained by taking the boiling point of the solution then minus the boiling point of the pure solvent. So let us consider about the freezing point of the solution. How the freezing point of the solution will be or will be affected after adding a solute into a solvent. Normally, after adding the solute into the solvent, the freezing point of the solution is decreased or is depressed. So the solution becomes to have lower freezing point than the freezing point of the pure solvent. From now, the laws of colligative properties is that if change in TF is equal to freezing point depression, since the freezing point will be decreased, that means it is a change also. That's why we say change in TF. From there now, the change in TF, since the solution, its freezing point becomes lower than that of pure solvent. So to find the freezing point, the change in freezing point, we just take the freezing point of the solvent, of the pure solvent, minus the freezing point of the solution. So the change in freezing point, we just find it by taking the freezing point of the solvent, then minus the freezing point of the solution. So whereby T solvent stands for freezing point of the pure solvent, and the T sol stands for freezing point of the solution. So now from the laws of colligative properties is that the freezing point depression is directly proportional to molarity. So from this equation now, also after removing the proportionality sign, then we put a constant. And our constant here is the known as cryoscopic constant or molar freezing point constant. So after removing the proportionality sign, now you will have Kf times the molarity, whereby Kf is equal to cryoscopic constant, or sometimes we call it molar freezing point constant. So if now we break down the molarities, what we did in boiling point elevation, then you'll have change in Tf will be equal to Kf times Ws times 1000, then divided by Ms, then times W naught. So this is now the equation that can be applied in finding out the freezing point of the solution after adding a solute into the solvent. Now from there now, we can go to some examples that are mostly confusing students or are challenging to the students, so that you can see how can you apply these formulas in determining the variable that will be asked in that question. The first example now, as you can see there, is about the boiling point elevation. And the example is written that 1.0 gram of non-volatile solute was dissolved in 10 gram of propanone. The solution boiled at 57.4 degrees centigrade. So you are asked to calculate the molar mass of solute, given that the ebullioscopic constant of propanone is 1.71 Kelvin kilogram per mole, and the boiling point of propanone is 56.2 degrees centigrade. Now, in answering such a question, first you have to start with the data given. So the data given in our question, the data given is that we have the mass of the solute, which is 1 gram. So mass of solute, which is Ws, is equal to 1.0 gram. But if we continue reading our question, that 1 gram was dissolved in 10 gram of propanone. So propanone is our solvent. Propanone is our solvent, and a non-volatile solute was dissolved into that propanone. So that gram, that means it is a mass of solvent. So the mass of solvent, let it be W naught is equal to 10 gram. And the solution boiled at 57.4 degrees centigrade, which means that after adding the solute, the solution boiled to 57.4 degrees centigrade. So we have the boiling point. Boiling point of solution, which is equal to, that is T solution 57.4 degrees centigrade. And also we have been given the ebullioscopic constant, which is the Kb, or the molar boiling point constant, that is Kb, which is equal to 1.71 Kelvin kilogram per mole. But and also the boiling point of propanone is 56.2 degrees centigrade. We have said here that propanone is our solvent. So if it is our solvent, that means that boiling point is for the pure solvent. So the boiling point of pure solvent, T solve, is given as 56.2 degrees centigrade. So from there now, what have we been asked? We have been asked to calculate the molar mass of the solute. So required is the molar mass of solute, and let us denote it as MS. So after writing your data, then what follows is to write the guiding equation of molar of boiling point elevation. So now from our equation that we derived, which is change in TB is equal to Kb then times the mass of solute times 1,000, then divide by molar mass of solute times mass of solvent. So in that equation now, we are asked to calculate the molar mass of the solute. So we have to make the subject MS, which stands for the molar mass of the solute. Now, molar mass of solute will be equal to Kb times Ws times 1,000, then divided by change in Tb, then times W naught, which is the mass of the solvent. Now, if we substitute our data from that equation, the molar mass of the solute will be equal to, our Kb here is given as 1.71 Kelvin kilogram per mole. So Kb is 1.71 Kelvin kilogram per mole, then times Ws. Ws is the mass of solute. So the mass of solute is 1 gram. So it will be times 1 gram, then times 1,000. Then divide by change in TB, whereby the change in TB, we mentioned earlier that it is calculated by taking the boiling point of the solution minus the boiling point of the solvent. So change in TB is T of solution minus T of solvent, then will be times now W naught, which is the mass of our solvent, which is 10 grams. So it will be times 10. Now this 10 will not be gram, will be now it is a kilogram, since we have divided by 1,000. That means it is to convert that gram into kilogram. So will be this is kilogram. And from there now, the T solution minus T solvent. So the MS will be equal to 1.71 Kelvin kilogram per mole times 1 gram, then times 1,000, divide by T solution minus T solvent. The T solution we have been given, which is 57.4 degree centigrade, and the T of the solvent is 56.2 degree centigrade. So if we minus 57.4 by 52.2, the answer will be, so it will be 57.4 degree centigrade minus 56.2 degree centigrade, then will be times 10 kilogram. So mind you, and be very careful here, most of the students are confusing. Here the unit of molar freezing point constant are in Kelvin, and the boiling point of the solution and that of our pure solvent is in degree centigrade. So you must be very careful here. If you want to change this into Kelvin, you have to change before subtracting them. Then how do you do? Is that you subtract, you change this one into Kelvin and this one into Kelvin, then you can minus, you get the answer that will be the same. If we minus it as they are in degree centigrade, the answer that you will get here will be the same to that you have after changing or converting this degree centigrade into Kelvin. So here you will have now ending to get that will be the mass of solute will be equal to 1.71 Kelvin kilogram per mole, then will be times there 1,000, that is gram, then divide by 57 minus 4, 57.4 degree centigrade minus 56.2 degree centigrade. The answer is 1.2. Now this will be Kelvin, then will be times 1,000, will be at times 10 kilogram. Now you must write the units of your data that you have substituted into equation, because sometimes you may be asked to show the cancellation of these units, and if you don't write, you'll end up getting the answer and writing the incorrect units of your answer. So from this question now, kilogram will be cancelled with that kilogram, Kelvin with Kelvin, and what will remain with gram per mole, which is the SI unit of mass of the solute. I'm sure everyone have a calculator, so use your calculator now to calculate that. If you use your calculator now, 1.71 times 1,000, then divide by 1.2 times 10. I'm sure you'll have the same answer as what I have got here. Then the mass of the solute is 142.5. And the unit will be what? Gram per mole. So that will be the unit of our answer. Therefore, it will be gram per mole. So that is now the molar mass of our solute. So you have ended now doing such kind of an example. So it is concerned with boiling point elevation of the solution. So let us now go to the second example, which now is for freezing point depression. And our example, if you see it, it is about the application of freezing point depression. The question says that the normal temperature in Himalaya Valley during winter season was found to be negative 10 degrees centigrade. And if 30% by mass of aqueous solution of ethylene glycol is present, then you are asked to judge if the solution will be suitable for car radiator. You remember the first question that I posed to you when I was starting explaining the concept of colligative properties. Then given that Kf for water is 1.86 degrees centigrade kilogram per mole, and the molar mass of ethylene glycol is 62. So as usual, you have to write the data that you have been given in your question. If you don't write the data, then you'll not get your answer, or you'll use a lot of time in finding the solution of that answer. So first you have to write the data given, and after writing the data given, then you can now think of the equation that will be now applicable in solving such kind of question. So the data given in our question, the normal temperature in Himalaya Valley during winter was found to be negative 10, which means that that is the temperature of the environment in Himalaya. So the temperature of environment is equal to negative 10 degrees centigrade. And we are told that if 30% by mass of aqueous solution with ethylene glycol, so 30%, if we convert it into mass of 100%, you'll get the mass of the salt that will be 30 grams. So mass of the solute, which is Ws, is equal to 30%, which is equal to 30 grams. So if the mass of the solute is 30%, it means that the mass of the solvent will be 70%. So the mass of solvent, which is W naught, will be equal to 70%. That is equivalent to 70 grams. So the mass of the solution now will be the total, which is 100%. So now the mass of solution is equal to 100%, which is equal to 100 gram. Now, here we have been asked to judge if the ethylene glycol, which is the ethylene glycol solution, is suitable for car radiator in that environment or in Himalayan. So what do we do here? That means we have to find the freezing point of ethylene glycol. And after finding the freezing point of ethylene glycol, we will be able to judge if that solution will be suitable in that car radiator to that kind of temperature. Therefore, if the freezing point of the solution will be lower than the freezing point of the environment, that means the ethylene glycol will be suitable for the environment, that is, which is have negative 10 degrees centigrade. But if the freezing point of ethylene glycol will be higher than the freezing point of the solution, that means the ethylene glycol will not be suitable for the car radiator, since under that temperature the solution will freeze, and if it will freeze, that means it will not be applicable in that car radiator. So from now we have been given the mass of ethylene glycol, the molar mass, not mass, it is the molar mass. The molar mass of ethylene glycol, which is our solute, that is MS, is equal to 62 gram per mole. As what I have said here, that means what will help us to judge that kind of question is the freezing point of ethylene glycol solution. Now, the freezing point of ethylene glycol is our solution, that is T solution, the one that is required to find it. And you remember, my dear student, we said that change in TF is equal to T of solvent minus T of solution. And here we are looking for the T of solution. We are looking for T of solution, but we don't have change in TF. But T of solvent we have, it is 0 degrees centigrade, because our universal solvent is water, and the freezing point of water is 0 degree centigrade. Therefore, here now we have to look for the freezing point depression. So, but from change in TF, we said is equal to Kf times mass of solute times 1,000, then divide by molar mass of solute times the mass of solvent. So now if we substitute our data that we have now, then the change in TF will be equal to Kf, which is 1.86 degree centigrade kilogram per mole. So Kf is 1.86 degree centigrade kilogram per mole, then times Ws, which is the mass of solute, and it is 30 gram, then times 1,000, then divide by molar mass of solute. The molar mass of solute is 62 gram per mole, then times the mass of solvent, which is 70 Now this will be kilogram since we have divided it by 1,000. So from there now, the kilogram will cancel with kilogram, then gram will cancel with this gram, then per mole will cancel with that mole, so you will remain with the unit which is degree centigrade. So the change in TF. So after substituting your data now into your calculator, now it is 1.86 times 30 times 1,000, then divide by 62 times 70, then the answer you get is 12.86. 12.86. This will be degree centigrade. So that is the freezing point depression, which means that is the amount of temperature that have been depressed. So to get the freezing point of our solution, which is now T solution, if we make it the subject here, will be equal to T solvent, then minus T change in TF. So the T of solution will be equal to T of solvent is 0.0 degrees centigrade at the freezing point of our solvent, which is water, then minus 12.86, which is the freezing point depression. Now the answer will be T of solution will be equal to negative 12.86 degrees centigrade. So this is the temperature of our solution, which is the solution of ethylene glycol. Now we have been asked to judge if now this solution will be suitable in car radiator in Himalaya Valley, which have a freezing point of negative 10. So if we compare between the freezing point of the environment and the freezing point of the solution, the freezing point of the solution is lower than the freezing point of the environment. So the ethylene glycol as our solution will be suitable for car radiator. So it cannot freeze at that temperature. So now it is suitable. Why is it suitable? Because the freezing point of a solution is lower than the freezing point of the environment. Therefore, hence the solution cannot freeze, because that is now one of the application of the colligative properties. So now we have used the freezing point depression in determining if your car radiator will freeze or will not freeze in that environment of Himalaya. Using these two examples, I'm sure the questions that I posed at the first for comparing the boiling point of the two beakers, you can now answer. And the second question that was about to judge why Dr. Musonde was advised by the engineer to replace the water in his car radiator Now you can answer it. And from there now, you'll be able to apply the whole concept of the colligative property of the relative molecular mass in solution in our environment and solving different challenges that are arising in our environment. So from there now, next period will proceed with another concept, which is about the solutions, or the solutions that undergoes dissociation or association. Because if you remember, this is about the solutions which do not undergo dissociation or association according to conditions for colligative properties. Now, let us end here, and for this time now, please, you are now at home. Keep in mind that you are at home because of Corona. Be safe and save your family, save your community, save Tanzanians, and save the world for coronavirus. Stay at home. Be abandoned with those laws and regulations that were abandoning you at school for you to remain safe. Okay, goodbye.